So we're going to talk about high-performance connectivity, specifically around Flux, and then with DataDirect. Aaron's going to do the DataDirect piece. So just to go into a bit more detail, Aaron specializes in DataDirect. I specialize in MarkLogic. So we've got as you can see, we've got a packed agenda. I'm going to give you an overview, an introduction to MarkLogic Flux, what it is, and later on we're going to do some demos. Aaron's going to do the DataDirect piece and tell you how you can use Flux in conjunction with DataDirect to get data in from third-party sources. And then we'll do the demo, and then we'll end for questions. So this is a really concise explanation of what Flux is, so I'm just going to read it. MarkLogic Flux is a single extensible data movement application that simplifies importing, exporting, and copying and processing data with regards to the MarkLogic platform. Now, if you've got any history with MarkLogic, then you'll know about MLCP, or MarkLogic Content Pump. That's used for getting data on and off disk in relation to MarkLogic. Corb, the content reprocessing in bulk, that's for reprocessing data that's already in MarkLogic. And then there was something called DMSDK, the Data Movement SDK, which was really a Java wrapper that interfaced with MarkLogic's REST API to allow you to do more complex stuff. And really what Flux does is it takes all those the capabilities of all those three tools and brings it into one. So whereas, say, MLCP was really focused on, like I said, the file system, with Flux allows you, in conjunction with DataDirect as well, to access third-party databases, so you can bring in stuff, as we're going to see in a minute, from, say, Salesforce into MarkLogic. And of course, that's a third-party application as well. You can also get data from and put data onto cloud storage. So, for example, Amazon S3, Azure Blob Storage. And then through Apache Spark, we've got access to the wider ecosystem. And of course, once you get data into MarkLogic, then you've got all the benefits of true multi-model, things like working with documents, graph, relational, and that sort of thing. So the interface is very simple. Primarily, it's command line driven. You type in the command and give it some options. You can load the options from an options file, which I'll show you in a minute. And then you've got, if you want to, you can transform the data on the way in or on the way out using REST extensions that can be written in XQuery or JavaScript that you can store in MarkLogic. And then if you really want to be clever, you can write your own standalone application in Java that interfaces and does stuff with MarkLogic, or you can interface with Apache Spark as well. So we've got demos for pretty much all of those. So to give you an example, let's say that you took some data from a third-party SQL database. You use DataDirect to bring it in to MarkLogic. That you might want to transform it on the way in, do a bit of massaging of that data. And then to get to consume that data, you can either use MarkLogic's REST extensions, get it out into a form Python could use those, or you might want to use Flux itself to then bring that data out en masse, do an archive dump, and then do all your sort of the Python business use cases like data science, reporting, and analytics. So there's been a lot of talk this morning about Gen AI, particularly around RAG. So Flux, the latest iterations around Flux, allow you to do some stuff that is very, very pertinent to the Gen AI use case. So first off is splitting documents. When you want to work with an LLM, you've got this constrained context window. And yes, they're getting bigger every year, but you've got to make sure that you don't overload the window with too much information. So as you load documents into MarkLogic, one of the things you can do is split those documents into chunks, and then it's those chunks that get fed into the LLM. And we've got a demo for that. So the other thing is that if you want to enrich your data through Semaphore, then you could, as the data comes in, you make a call out to Semaphore, that goes and does the enrichment, so you can pull out now discrete pieces of information from your documents that enriches the data, makes it more valuable, so that when you send it off to the LLM, it's more capable of answering those questions. And then with vectors, similar thing, we can, upon ingestion, we can make a call out to a vector embedding endpoint. We send it some text, it comes back with the vectors, we bring it into MarkLogic, and now, of course, with version 12, we can index that data and do full vector querying capabilities on that data. So what it means from a developer's perspective is because now all those three capabilities are in a single tool, it means that makes your life easier as a developer. And from a data engineer, similar thing. You can much more quickly meet your business objectives according to what you're trying to achieve. So I'm going to hand over to Aaron, and then he's going to do a little talk, and then we'll get on with the demos.
All right, well, thank you everyone for coming to listen to this. I've been with DataDirect about 8 years. Wanted to give you a real quick overview of DataDirect. We've been a part of Progress since I think 2003 is when we were acquired, and actually go back into the 90s. And really came about as helping define the ODBC and JDBC spec to move data and for SQL interface to get data out of SQL and relational databases. And we've really become the standard in the industry for that. So 8 of the 9 top BI vendors embed our connectors. You'll see them across a wide range of Fortune 100 companies. And then many of the ISVs also, software companies, embed our connectors for their ETL and other data integration projects. I'm talking about companies like SAP, Informatica, Oracle, all rely on us. So oftentimes you're using DataDirect under the covers. Kind of came up in some of the conversations this morning with MJ. Talking about the roadmap. So that even then carries on though into tens of thousands of companies using our connectors internally to solve their BI and analytics needs. So it's pretty common to come across someone using our drivers all over really all over. I mean, millions of users are always relying on DataDirect. So with regard to Flux, it really comes to focus on our JDBC connectors. And we've offered connectors across a wide range of data sources. So relational sources that you'd come to expect, the SQL Server, Microsoft Fabric, Oracle, Postgres, MySQL, CE. And you might be thinking, I can get those drivers from the vendors. And we run into that quite a bit. But people come to us because we tend to be more performant. We tend to make better use of memory and CPU when you're taking advantage of our drivers. And I'm also doing some things like intelligent caching, connection pooling, and reduce latency. So really try and improve the experience that people have with those connectors. And then also bringing additional authentication methods and SSL encryptions where security's become a real focus in the connectors. And then also having one vendor to deal with. You're not having to go to all these different vendors to get support for what they consider a free driver. So that is the relational piece. But one place that I think DataDirect has brought a lot of value over the last number of years has been against sources that don't normally work with SQL. So I'm thinking of Salesforce or S4HANA or Google Analytics, things that use maybe SOAP or REST endpoints or proprietary protocols. And what we've done is created a SQL engine that runs right inside of the connector. So we can put that relational model on top of what's generally not a relational data source. So a couple examples here of some of the sources that we connect to. Dan. So you'll see, the ones I mentioned, you'll see, like Google BigQuery or Snowflake on there, Amazon Redshift. So these would be kind of our out-of-the-box connectors. But one thing that this list is missing is all the sources that you might have that we don't have a connector for. So I don't know how many people deal with REST APIs. I'm assuming pretty common occurrence. And anybody ever struggled doing like BI and reporting against a data source that only has a REST API? You want to connect Power BI or Tableau or MarkLogic or anything to these different data sources. Is that something anyone has encountered? So we have a solution for that. That's what we call our autonomous REST connector. So what this is a standalone JDBC or ODBC driver that knows how to sample the data that's coming back from the REST API, JSON or XML, and can actually build out by normalization like a schema map to that data source. So we can actually understand the JSON that comes back, if it's an array, a nested array, and from that create a relational model on top of that. We handle the authentication, whether it be OAuth or token-based or header bearer tokens. We also take care of any pagination needs that you might have, and then we can also handle push-down parameters to that API. So we really try and make it as efficient as possible. And that's all ends up generating a configuration file. So when we get to say like Flux, all you're doing is pointing to a JDBC connector with a configuration file, and it knows how to speak to these different REST APIs. We also have a user interface that makes this a lot simpler to use. So in the middle here, you'll see we're connecting to a SpaceX API called Launchpads. On the left, you'll see all of the fields that we've created. We pick up the primary keys, the field lengths, the data types, all that can be customized within this user interface. And then on the right is where you can set up any push-down parameters or the pagination. So very easy to configure. And out of this comes that configuration file that I mentioned. And then in the middle, you'll see the SQL view of what this data looks like right on top of that REST endpoint. So I can easily issue a simple select star in our testing tool and return that information right from the API in real time. So to make this a little bit easier, we also include some model or sample files right out of the box. So you can get started at connecting to things like Jira or AHA or really anything you can come up with. This helps you get started. And if your source isn't there, maybe it's an internal API, then it's easy to start right inside the composer to do that. So for our demo today, we're going to show using the Salesforce connector I spoke about in the beginning. And Stephen's going to demo using Flux to import that data directly into MarkLogic. And the nice thing about the Salesforce driver is it knows how to deal with the accounts, contacts, leads, any of the tables that are native, or I guess entities or objects that are native to Salesforce, as well as any custom objects that might be created. It will discover all of those and put that relational model right on top of them. The other thing is that if Salesforce makes any changes to their API, it's always a challenge with these REST APIs, that becomes our problem and not your problem. So we'll update our connector to solve that. So with that, I'm going to hand this back over to Stephen.
Okay. I'm going to show you a tiny little Java snippet of program that is going to ingest some data. Then we'll do some JSON, CSV imports, and then reprocessing as Corb used to do. And then we'll do an archive dump. So let me see if I can get out of here. For this first example, we're going to load some data from salesforce.com. So I'll go into this directory here. And you can see here I've got a shell script. And all this boilerplate here is doing is just getting some environment variables from this file. So the environment path for the Flux binary, and then the credentials you can see with the $sign. So what we're doing here is we're going to use this instruction, this Flux instruction, import JDBC. We're going to supply the details to connect to Salesforce, and then we're going to also supply the details to connect to MarkLogic, and the rest of the options are in this options file, which is here. Now you can see that we're using this particular driver. This is the query that we're going to use to get data from Salesforce. This is the database that we're going to put the data into within MarkLogic, and these are the permissions and collections that we're going to assign to those documents. So if I run that,
Okay, and you'll see if we go into Explore here that we've got these documents in here. So these are straight out of Salesforce, and we can see also that they've been assigned to particular collection and particular permissions are to be specified. Great. So what I'm going to do, I'm just going to clear this down, and we'll go on to the next example. All right, now I'm going to go into this directory, and this is the example where we can create a very, very simple Java program to load documents into MarkLogic. So you can see up here, we're importing the Flux library. These ones are just to get the environment variables from that .env file. So in other words, all this lot is just here to create this connection string, which is passed in here. Okay, and then we're just specifying the path to the data. In other words, this is this one. So we've got 5 XML documents that we're going to ingest, and then we're going to assign some collections and permissions for those documents. So this is a Gradle project. So we're going to run this one, which just specifies the path to a particular version of the Java runtime. And this is going to compile and build the program, the Java program, and then it's going to go and actually load the data into MarkLogic. If we take a look, there we go. And if we go into one of these documents, so this is a PubMed article. As I mentioned, it's XML. And now you'll see that this URI is really the path of where it came from on the file system. And we'll talk about later about how you can use a URI replacement to make that URI meet your requirements in terms of URI naming. So again, I'm just going to delete these, go on to the next one. Okay, so now we need to go to this folder here. Right, so this example, again, we're getting the variables from the .env file. This time the instruction is import files. So if we look in the options file, we can see that this data is coming from here, which is just 6 JSON files. We take a look. So same database, that's where it's going to put the documents into, and we're doing permissions, collections, and then, as I mentioned, we're doing this URI replace. So we've got this regex here, which we're going to use to identify that part of the URI that we want to replace, and we're going to replace it with /data. So now if I run this, you can see, well, actually, yes, you can see that we've got a nice URI for each document, and you can see that we've now imported that JSON as is. Okay. Now, one of the things that Flux supports, as we talked about, was this idea of being able to split data as it comes in other words, chunk it so that we can send smaller payloads to the context of the LLM when we have these Gen AI use cases. So if we consider these two documents here, these are the first two chapters of Persuasion by Jane Austen, and you can see that the paragraph here, the text, is within this chapter text part of the document. In other words, if it was an X path, it would be /chapter/text. And this is what we're going to chunk. So if we look at the options file, so you can see there, this is the path for splitting, which is this lot here. And then it starts to get interesting down here. So this is the piece of the configuration that says where to find the data that we're going to chunk. The chunk size is the maximum number of characters that we're going to have per chunk, in this case 1,000, and then how many chunks per sidecar document we're going to put in there. So it's just going to be one chunk per sidecar document, and then the format of that sidecar document and the root name of that chunk. So let's run that and we'll see how that goes. All right, so now what you can see, there's the original document this is effectively unchanged. And then here are the sidecars, here are the chunks. So if we look at this first one, we can see that we have it's chunked it from Sir Walter Elliot to Elliot of Kellynch Hall. So if we go back to the original document and have a look, it's done it from here to here. Now, you can see that this is 716 characters. If we'd gone down to the next line break, it would have blown over the 1,000 characters. So really what the chunking algorithm has done, it's made an intelligent decision saying, right, well, I'm going to break on the first line break that is before 1,000 characters. And one of the things about splitting within Flux is that you can write your own or be very specific about what or how to chunk up the documents where that break is. But we're just using the default. Okay, so let's move on now to classification. So you can see that we have this classification options file, and this is coming from here. So we have just the Apollo, just a single document. This is a description of the Apollo moon landing. And I'm going to show you here that we have a knowledge model within Semaphore. Actually, let me go back a second. I'm going to go into the master. And you'll see that we've got people, astronauts, agencies, and so on. We've got places, points of interest, Sea of Tranquility, of course, on the moon, and so on. So we've got this model, and what we're going to do is we're going to, as that document comes in, we're going to make a call out to Semaphore to have it classified, and then the results are going to come back from Semaphore and be stored in the document. So if we look at the options here, what we've got is this is the credentials to, or the configuration to talk to the Semaphore instance, the local host on what port, we're using HTTP rather than HTTPS, and the path of the call we're going to make is just slash. There's no other subpath in there. So let's go and run this. And if we have a look, we can see now that the document's in there. So here's the original text. And what it's done is it's got the output from Semaphore and embedded it at the end of the document. Now, if you wanted to, you could then transform some of that information so that it's maybe more palatable to your use case. But I'm going to delete that and we'll go on to the next one. Okay, so now we have this. We're doing this example. So the instruction here for this one is import delimited files. So we're going to use this options file. And you can see here that the path is CSV. And this is just a simple CSV file. And what's of note here is that we're saying you rather than have a URI replace, we have a URI template. So each document is going to be /transactions some identifier.xml. With that ID, the fact that it's in braces there, we're going to get that from the first column, this ID column of each transaction. The other thing to note is that by placing XML root name in the options file, it's essentially saying it's inferring to Flux, don't create JSON, create XML instead, and the root name is going to be transaction. So let's go and run that one. And there we go. You can see it's created the XML. It's wrapped it with the data with a transaction element, and there you go, all the information in there. And of course, you can see the ID there as well matches this one. All right, now I'm just going to do a standard run with this one. So again, we're going to import the same file, and we're going to import it as JSON this time because it's using the default. We're not specifying XML. And what you can see is that there's no transaction property name. In other words, it's a flat list of key value pairs. So it might be that you want to place a key of, or wrap that information with a key, let's say transaction, and so that it's easier the data is easier to work with. So to do that, we can create a transform. And what the transform receives is the document and some contextual parameters. And then really it's just a function that will transform or modify the data. So what we're doing is we're getting the content in other words, the JSON document, turning it into a JSON object, and then just wrapping it in this transaction element and returning it. So we load that using this command here, transform load. And now if we go into the options file, we can see that all we need to do is refer to it by the name we gave it in the transform. So for example, we gave it a name when we loaded it in of add wrapper. So that's what we're going to use here. So if we now run this, what it now means is that each document has the transaction wrapper, which is great. So if we didn't have the URI, we could just look at this document and say, oh, yes, it's a transaction. It gives us a little bit more information. The other thing is that we can do an XPath expression, and it will actually return all the documents, which it would have been difficult to do that otherwise. All right, now you can see that if we take this first one, these are the 5 key value pairs that we have. Now, it might be that we want to modify that data. As an example, add a currency of US dollars to each of these documents. And this is where reprocessing comes in, the capability that is in core. So let's go to here. And you can see now that the command is reprocess. If we look at the options file, it's specifying this reader file and a writer file. So what the reader file does is it selects a list of document URIs of the documents that are going to be reprocessed. So in this instance, all we're doing is we're using a CTS collection query. So it's saying every document within my collection 1 is going to be reprocessed. And so it returns a list of URIs, and those URIs, one by one, are sent into this piece of code, this writer code. You see we're importing this external variable. We're using that to get the document, convert it to a JSON object, and then we're going to add the key value pair of currency equals JSON. That document object now gets sent back into a document insert with the original permissions and collections that were assigned to the document on the initial intent for ingestion. So let's run this. And finally, what you'll see is that now each document has this currency equals JSON property. All right, now finally, we're going to do an export of this information. So I'm going to go to export files. And the instruction is export files. We look at the options file. We're specifying a path for where the data is going to be exported to. Let me just get rid of that. So it's going to be exported to data export JSON. And then this is the query that we're going to use to select the documents that are going to be extracted. And it's essentially saying any document where the merchant value is 1, 2, 3. So remember that this information came from the CSV file. So we have the merchant number here, 1, 2, 3, 1, 2, 3. You've got some that are 2, 3, 4, some that are 3, 4, 5. So it's only going to export these records here, 1, 2, 3, 4, 5 records. And there we go. So that's exporting documents, and that's the last example.
So, yeah, so what you've seen is that we can provide all this capability in one tool now. And of course, we're keeping up with modern technology in the case of, say, Gen AI. DataDirect can be used if you've got more advanced use cases, bringing that data in from third-party systems. I think we'll wrap it up there. Any questions? Yes. You only get one, sorry.
So it connects directly to forest and operates on the forest level. So when you have multiple threads, each thread goes to the specific forest and operates on the forest.
So I know MLCP had that capability.
And what about Flux?
That is a good question, actually. I'm going to have to take that one offline if you
Okay.
want.
The second question is it possible to extend the Flux with Java code, not with JavaScript or XQuery transfer modules? So when you need to implement more complex logic, either for splitting or outputting the files, is
yeah, so you would use either like the Java example I showed you, or interface with Apache Spark.
Yeah, but can you, for example, plug in Java function for, do some transform or calling the APIs and so on, so you can do more complex stuff?
So you're talking about from within a transform itself?
Yeah, but using the Java code, not JavaScript or XQueries.
No, any transforms would have to be done through MarkLogic.
Okay.
Yeah. But then, like I said, the best thing to do, I think, would be to, so you would use Java or Apache Spark for that. You wouldn't use like the server-side transformations for that sort of thing.
Okay.
Yeah.
And the third one, the last one, what about the error handling? So, for example, when you move the huge amount of data and something goes wrong in the middle, so you don't need to start from scratch.
Yeah, so it will tell you, when you run through the command line, it will tell you what's failed.
Okay, but for example, let's imagine you need to move 1 terabyte of data.
Yeah.
And in the middle, something goes wrong and process fails. Yeah, so is it possible to start from the point where it failed, so you don't need to again load the content that is already loaded? And
the default command line stuff, if you're really concerned about that sort of thing, I think you would be better off using something like Apache Spark and doing the manual handling of those errors yourself, because either that or you've got to redirect the output from a command line running of that, and then sort of work out how you process that text file to then work out what to reprocess, what to re-ingest. You'd be much better off handling that yourself through like something like Apache Spark.
Okay, thanks.
All right, no more? Going on. Thank you very much.